Hey everybody, welcome to how to solve exponential equations. So here is the process, and it's not unlike any process that you've used to solve kind of any equation. So the first thing you want to do is you want to isolate the exponential to one side, and this may be isolating to like apart from each other, but you want to clear out all the garbage first. That's kind of what number one says. And then number two, we want to use the inverse function to kind of undo, which is what we always use. If we're multiplying, we divide. If we subtract, we add. Except for the inverse function of exponentials, we're going to log or we're going to ln both sides, depending if you're using a regular exponential or if you're using e. And then we're going to solve for the variable. So these are the examples we're going to go over. So we got these guys here, and we're going to go over them in this order. So these 5 examples are coming up and they'll be done. So the first one, how do we solve for e to the x equals 36? Well, the first step was isolate the exponential, which means we're going to clear out the garbage. So the first thing we're going to do is divide everything by 4. So this guy will be e to the x. 36 divided by 4 is 9. And then our step is we are going to ln both sides, because ln is the inverse of e. So we ln both sides. Ln and e inverses, we get x equals the ln of 9. And the ln of 9 as a number is 2.2. I'm going to drastically round 2.2. There we go. Okay, let's see another one. Where is my pencil? There it is. Okay, 3 times parentheses 1.3 to the x equals 5. Okay, again, clear out the garbage. So we're going to divide everything first by 3 to get rid of these. So we have 5/3 now on the right. So 1.3x equals 5/3. The next thing we're going to do to undo the exponential, we are going to log both sides. Log both sides. And now the x gets to drop down in front because rules of logarithms. So this will become x log 1.3 equals log 5/3. How do you get rid of anything that's with the x? Oh, you divide. So our next step is going to be now to divide by log of 1.3. Remember, log of 1.3 is just a number, so this is no different from just like dividing each side by 5 or something. Those guys cancel out. So now we get x is equal to log of 5/3 divided by log of 1.3, and let's see exactly what that is. Log of 5/3 divided by log of 1.3, and our calculus says it's approximately 1.95. 0.95. Rounded. So I'm using 2 decimal places just because I think it looks prettiest. Alright, next. So let's bump up the level of complexity here. Alright. So now we have more than one thing in the exponent. Also, there's exponentials on both sides. So these things are already isolated. So, like, this is what I was saying kind of at the process slide here. There's one on one side, one on the other. There's no kind of garbly goop here out in front of either of them, so we're good. So let's just start off by taking the log of both sides to get the exponent out of the exponential. Because of rules of logs, that whole exponent gets to drop down in front now. So now this will become negative 2x minus 1 times log of 3, and this will become x times log of 2, right? Power rule of logs. The power gets to drop down in front. Let's do some expanding. So I'm going to do a distributive property here. Log of 3 minus 1 times log of 3 equals x log 2. Okay, I really need all my x's together, so that's exactly what I'm going to do. I'm going to subtract x log 2 from both sides, and also add log 3 on both sides. And now what I'm going to do is I'm going to factor out the x because I'm still trying to, not 3, 2, log 3. So I'm factoring out x minus log 2 equals log 3, and I need that parenthesis there. Now I can divide by this whole thing, and x will just drop out, and we'll get log 3 over, we're dividing out by this, which means this goes down here, negative 2 log 3 minus log 2. And when you put that big old nasty thing into the calculator, you'll get negative 0.38. And we're done. So the idea here, after you log both sides, your next trick is to then isolate your x. And sometimes you may have to put them on both sides and then factor that x out. That's a really useful algebra trick, and it's used a lot. Put everything on one side, factor out the variable, and then divide out by the rest of the stuff. That technique is used often. So we see that there. Next, all right, another e to the x problem where we still have some gargly goop here. So let's clear out said gargly goop. So let's subtract 7 from both sides. So we get 5 e to the x equals 32 minus 7, better known as 25. And now let's divide both sides by 5 to get rid of, again, so much gargly goop. So e to the x on the left, 25 divided by 5 is 5. Okay, what do we do now to get the x out of there? What is the inverse of e? It's ln. So we're going to ln both sides. When we ln both sides, inverse, so x will just drop out. The right side is going to be ln of 5, and ln of 5 evaluates to, on a calculator, to 1.61, rounded, 0.61. Alright, and done with that one. So now let's go to a challenge 1, because now we have a square involved. Alright, so clear out all the crap first. So we're going to add 8 to both sides. 2x squared plus 1. Add 8 to both sides. 4 plus 8 will give us 12. This is an exponent. It's not an e, so we're going to log both sides here to get that exponent out. Sorry, the variable out of the exponent. So now that gets to drop down in front. So now we have 2x squared plus 1 times log of 10 equals log of 12. That's a 12. Alright, what is log of 10? 10 to what power is 10? Oh, it's 1. Log of 10 is 1. So this is all 1, so that's basically 1 times anything itself. So that's going to turn to 1, so that gets to kind of cancel out. So we get this, log of 12. Let's see, now what do we have to do? We need to isolate this x, so let's subtract 1 from both sides. So we get 2x squared equals log of 12 minus 1. Now let's divide everything by 2. X squared equals log of 12 minus 1 divided by 2. Now let's take the square root of everything, and this is going to get extremely messy. So x equals plus or minus the square root of, and I'm going to throw this into a calculator and turn it into a decimal. So log of 12 minus 1, log of 12 minus 1 divided by 2.0, call this 0.04. So this will evaluate to x equals plus or minus square root of 4. Now, is this a valid answer, yes or no? Well, what is the domain of exponentials? Well, the domain of exponentials is all real numbers. However, the range is limited. Okay, so the domain of exponentials is all real numbers. So in fact, anything that we want to plug in x for x is fine. Okay, so both of these answers are fine and valid in this case because, again, domain is everything for exponentials. So I hope you enjoyed this video. If you have any further questions, please, please, please don't hesitate to ask, especially if you want any kind of further examples or further clarification on anything. Hope that helped. See you guys in the next video.